A pleasant evening to everyone, to my dear classmates, most especially to Dr. Mirna Pipito. Thank you so much for this chance, for this opportunity to be able to present this topic on multivariate analysis. So, by the way, I am Richelle Kisto. I am from Bohol. I am currently connected with Sum High School, secondary school here in Bohol, handling English subjects. So this class is actually one of the last subjects that I'm taking for me to finally take the comprehensive exam, hopefully this first week of May. That would be very soon, hopefully. So going back to my task, that is all about presenting the overview of multivariate analysis, including the definition, importance, characteristics, and categories. And what is multivariate analysis? As teachers, researchers, research enthusiasts, or perhaps analysts, or even as ordinary people, every day we are faced with a lot of queries and problems, and we are challenged to look for answers or choices. Sometimes we cannot just say, like for example, as a teacher, sometimes we'll be asking why those students fail, or why are there students who are non-readers. We cannot just pinpoint a certain factor. We need to analyze and we need to consider all possible factors, or in this class we can call it variables. So that is the same with multivariate analysis. This is a technique, a method, actually not just one. It comprises a lot of statistical techniques and methods which study into the interrelationship of multiple variables, as the name suggests, multiple or many variables, looking into the interrelationship about several variables and drawing cause-effect conclusions about their constituent parts. So broadly speaking, multivariate analysis is an inquiry into the structure of interrelationships among multiple random variable analysis or multivariate datasets. Datasets that will be included in the study may be metrical or qualitative or numerical, or it could be categorical or descriptive, or it could be a mixture of two or both. Multivariate analysis, or MVA, is a method of gathering multiple sets of data and drawing cause-effect conclusions about their constituent parts. Okay, so this time we're going to talk about the importance of multivariate analysis. So if you're going to look closely into the process or into the methods or techniques, you will discover that it allows us to examine a lot of things. It allows us to make multiple measurements on items and subjects with covariant structure. Likewise, it also offers a more complete examination of data by looking into all sides, all possible independent variables or factors, and their relationship with each other. It helps companies, like for example in the marketing field, or it helps them to predict future outcomes, improve efficiency, make decisions about policies and processes, correct errors, and gain new insights. Furthermore, it builds upon univariate analysis and bivariate or two-variable analysis, because this is the third type of analysis, right? Univariate for one variable, bivariate for two, and then this one multiple variate or multivariate for many variables. So this is especially useful for analyzing complex data sets, allowing you to gain a deeper understanding of your data and how it relates to real-world scenarios. One of the most useful methods to determine relationships and analyze patterns among large sets of data is multivariate analysis. It gives us the trends and patterns. Like for example, if we're gonna ask if white shoes will still be trending in the next few years, or K-pop or K-dramas will still be in for the next few years. So if we're gonna study on that, we can look at the data in the previous years, and it would be a good basis for our predictions like that. So it is particularly effective in minimizing bias if a structured study design is employed. However, complexity of the technique makes it less sought out models for novice research enthusiasts. So there's also an Achilles heel in this technique, just like any other. There are also weaknesses. So in this, one of its weaknesses is its complexity in the techniques, because it is composed of different techniques and methods, and that is why for these research enthusiasts it would be difficult to use right away. But later on, if we are going to study more into each method or technique, then it will prove to be very beneficial to researchers and to teachers perhaps, or to analysts. It is found in almost all the disciplines which make up the bulk of policy making, especially in economics, healthcare, pharmaceutical industries, and applied sciences, sociology, and so on. So it has a foothold in the field of behavioral sciences like psychology, psychiatry, and allied fields because of complex nature of the discipline. In addition, there are many reasons why MVA or multivariate analysis is preferred or utilized by many. So one of which is the reliable patterns or trends of data. Another one, clear comparisons, filtered and wanted information and biases, simultaneous treatment of multiple factors. So we are assured that if we are going to use this MVA, then the data has a lot of features, credible features. Let's talk about characteristics of multivariate analysis. The features or characteristics. Number one, data reduction. To represent the phenomenon under study as simply as possible without loss of information. So, other types or tools in multivariate analysis wherein they're gonna simplify the data, but without sacrificing the value or the content of that data. So another one, number two, is the groupings or the data organization. Forming groups of similar objects, sorting or grouping of data depending on certain characteristics. So similar data will be grouped and the like. So it would be clearer, it would be easier, because although there are multiples of variables, but then it was already categorized and sorted, so it would be easier. Then number three, data interdependency, understanding the relationship between variables. So also there are some techniques in multivariate analysis wherein the datas are there or the factors are there not because it is cause and effect or it is dependent or independent, but because there are connections or relations among the variables. Then number four, investigate relationship among variables. Is there a relationship among the several variables in the data? So if yes, then what is the nature of that relationship? So in multivariate analysis, it also studies the interrelationships of variables. So example, what is the relationship between risk-taking behavior and performance of top-level business executives? So we're going to look into the relationship of those mentioned variables. Number five, prediction. So how can the relation between variables used to predict the values of a variable of interest? So predict success in college based on the test scores in high school of students. In multivariate analysis, we can have that feature, that prediction, that although we do not certainly know what will happen in the future, but because of the data gathered and analyzed from previous records, then we'll be assured that that somehow the trend will be the same. And then number 6, hypothesis construction and testing. In researches or studies, we construct our hypothesis, and MVA will help us to test or to validate our assumptions or to reinforce our prior convictions, to test the hypothesis of interest. Okay, so that would be all for the characteristics of multivariate analysis. Let's now move on to the categories. Earlier, MVA is not just one, but it is actually a bigger umbrella of a lot of techniques and methods or analysis. So some references will call it categories, some will call it tools, most will call it techniques. So anyhow, all of them are types or under multivariate analysis. These techniques or methods allow you to gain a deeper understanding of your data in relation to your specific business or real-world scenarios. Techniques are majorly divided into two. MVA will have two major divisions. One is dependence technique and the second one is the interdependence technique. What is dependence methods or technique? This is used when one or some of the variables are dependent on others. Dependence look at cause and effect. In other words, one variable causes some change in the other variable, which is the dependent variable. So the independent variable or the predictors causes some change on the dependent variable. Questions like, are the two variables dependent upon others? If the answer is yes, then that method or the technique falls under dependence method. Techniques such as multiple regression analysis, multiple discriminant analysis, multivariate analysis of variance like MANOVA, and canonical analysis are under these categories. The second method or technique is interdependence. Interdependence is used to understand the structural makeup and underlying patterns within a data set. In this case, no variables are dependent or independent. We do not label them like that. There is no causal relationship. Rather, it seeks to analyze, to give meaning to a set of variables, to group them together in meaningful ways. Here in independent methods, variables are not connected through cause-effect, but somehow there is a connection or similarities. Under this technique are factor analysis, cluster analysis, multidimensional scaling or MDS, and latent structure analysis. Let's delve more into each technique or category. Number